All right, guys. I'm out, probably because my wife has had a baby at this point. I'm sure he's super cute, and I'm probably asleep, and my wife is probably elbowing me to get up to go get the baby. But I sleep through anything, even her elbows. All right. Today we are going to be starting on Chapter 8. I know we just started Chapter 10, but we're going to go back and do some what they call like SOHCAHTOA or sine, cosine, tangent, or Oscar has a heap of apples. So we're going to deal with some more right triangle stuff. It's, I think, really important. I wasn't sure if we would get to that this year or if you would cover it in Algebra 2. But I think you guys should at least have an introduction to it. So we're going to go ahead and get started on that. So that's what we're going to be doing today. How to use right triangles and the angles of those right triangles with some properties on the calculator called sine, cosine, and tangent to be able to find out the lengths or angles of the triangle that you don't necessarily know, given some that you do know. You know, like Mr. Seekins, I have no idea what you just said. Well, we're going to figure that out. All right, so something that's pretty basic on a right triangle, or very interesting, I should say. If you have a right triangle, ABC, if you have this right triangle here, A, B, C, and then you take the height from the hypotenuse, or the altitude from the hypotenuse to the 90-degree angle, it turns out that that also forms a right triangle. So we end up with a right triangle DCA, and we end up with right triangle DCB. So you end up with three right triangles, and the other thing about that is they're all similar. You see this squiggly line here? That means similar. So if you take that altitude from the hypotenuse to the 90-degree side, you end up with three similar triangles. So write a similarity statement comparing the three triangles. So just like this, right here, we want to write it such that if you take a look here, they said ABC, ABC, they ended with the 90 degrees. So let's take a look at this. ACD, ACD, you ended with the 90 degrees. CBD, CBD, you ended with the 90 degrees. So that's going to help us to be able to figure out how to write that similarity statement. We're going to want to finish at the 90 degrees. So we're going to start at the side opposite and work our way through. So let's go ahead and first figure out what those triangles are. We have UZW, UZW, and then you have UVW, UVW, and then you have ZVW, ZVW. But we're going to need to make sure that we write these correctly. All right. So UZW, UZW did not end. We need to end with the Z as our right triangle. So we're going to start with the short side first. We're going to go from Z to W, or I guess we start on the short side. We're going to end with the Z, so we're going to start at W, and then we say W, U is the hypotenuse, WU is the hypotenuse, and then we end with the 90 degrees. And we're going to do that same thing here. Is similar to, we're going to do the next one. The hypotenuse is UV, W, and then that is going to be similar to We have the ZVW we're looking at right here, and we want to make sure we take the hypotenuse first and work our way to, so VWZ, VWZ. And then those all end up being similar because we start with the hypotenuse and we go away from the small angle. So we're working our way away from the small end. So you'd be like, oh, Mr. Seekins, we made a mistake right here with, we went UVW. We ended up going towards the small end. We want to go away from it. So it needs to be VUW, VUW. And then they all end up similar. So if one of you guys caught that, go ahead and give yourself the +5. So all of those are now similar. Now, if that was too confusing for you, it might actually help if we sketch it out individually. Let's first sketch out this in such a way so that the hypotenuse is, so the long side is on the bottom. So that the long side is on the bottom. And so long side here, short side, hypotenuse. Well, that didn't end up right. Long side, short side, hypotenuse. That didn't work either. Long side, short side, hypotenuse. And then do a right triangle. Long side, short side, hypotenuse. And then long side, short side, hypotenuse. And then long side, short side, hypotenuse. And then we label those. Let's start with the U is U, V, W. And then the long side again. That's going to be, that's the hypotenuse knit there. W, U, Z, I think. No, that's wrong. Because ZW is the short side, and ZU is long side, and UW. And then the short side is ZV. Z is the 90 degree, V and W. So now that we have this, we can go ahead and just work our way around. We say WUV, WUV is similar to, and work our way around here. I want to start with the, I want to end at the 90 degree, right? So I'm going to start here and work my way around. And start here and work my way around. Start here and work my way around. So this is going to be UVW is going to be the same as UWZ and WVZ. And these are written in one of the three ways that you could write the similarities. Notice how the W ends here, but it's UVW instead of VUW. Well, that's because if you start here and go this way, that would have been this one. If you start here and go this way, that would have been this one. And if you start here and go this way, that would have been this way. So depending on whether you go clockwise or counterclockwise, it might help to write your triangles out first, and then you write down your similarities. Then you would know that you're right the first time. Either way works. All right, so consider the proportion. So we have a over x is equal to x over b. If we're going to solve for x, we need to multiply this up and across. So we have a is equal to x squared divided by b. And then we need to get rid of this. So we multiply up and across. And we end up with ab is equal to x squared. And then to solve for x squared is equal to ab. You square root both sides, and you end up with x is equal to the square root of ab. That's what they have right here. And we call that the geometric mean. And then you're going to ask, what do we do with the geometric mean, Mr. Seekins? That's what we're going to try and figure out after we start solving for the geometric mean the first time. So hold on to that question. What do we do with the geometric mean? After we try some problems where we're finding the geometric mean. I'll give you a hint though. The geometric mean is used in a relationship of a right triangle. Do you remember this right triangle that we were talking about? And then if we go like this, right? There's a relationship between these three similar triangles that uses the geometric mean. So we'll get to that. But right now I need to make sure that you know how to do the geometric mean. So x squared is equal to ab. Do they give us an x squared? No. They said find the geometric mean. The x squared is our geometric mean, so they give us a and b. Doesn't matter which one is a and b. So we just say is equal to 4 times by 25. So x squared is equal to 100. Take the square root, and we get x is equal to 100, not 100, is equal to 10. Is equal to 10, but remember, x squared means that you have two answers where you have x equal to negative 10, positive 10. But remember when I said that the geometric mean has to do with a relationship of this right triangle that's going on here? Well, since it's got to be a relationship, this distance here, A or whatever, and this distance here for B, those are both positive distances. So X is going to need to be a positive number as well. So we're just going to pick X as 10, and we're not going to worry about this negative 10. So we're going to do this again. Find the geometric mean. So find the x. X squared is equal to AB. So we plug that in. X squared is equal to 5 times by 30. So x squared is equal to 150. And then we take the square root of x squared and the square root of 150. But it says simplest radical form, so you don't plug it into your calculator. You're going to take 150, and you're going to factor that out into 5 and 30, and factor that out into 5 and 6. So you see these numbers right here. We combine those together, and you get 25. Square root of 25 times the square root of 6. And so the square root of 25 is 5. So 5, the square root of 6. If you are having trouble doing simplest radical form, go on to Khan Academy and practice it. That's the only way you're going to get better. We've been going over this for like 3 months now. All right. So use theorem 811 to write proportions comparing the side lengths of the triangles formed by the altitude to the hypotenuse of a right triangle. All relationships in red involve geometric means. Do you see this here? BA for the leg, this leg, and this leg is BA. And then you have this leg and this leg is YH. And then you have this leg and this leg is HX. So you notice here how you have an H and an H. So then you end up with something that when we had an H and an H, so that turns out to be essentially our X. So this would be our A and our B in this case for our geometric mean. Remember, it was A over X is equal to X over B, right? Notice how it's X and X. So that gives you AB is equal to X squared. So we do the same thing there. That'll be YX is equal to H squared. So you notice that H is our geometric mean. So we're going to stop there, and I'm going to give you the homework. I just wanted you to be able to see how you use the geometric mean, and we won't use that until Friday. So homework. All right, so your homework is going to be on 521. It's going to be in section 8-1, and it's going to be 15 to 23 all. Should be pretty simple stuff. If you need help, ask your neighbors for help. And if you need help, you maybe ask your teacher to email me some questions, and I will try to do those problems for you in a video. All right. Thanks, guys. Enjoy yourselves. My wife is telling me that they're probably not going to enjoy themselves with math homework. And I was like, yeah, you will. It's Mr. Seekin's class. All of you guys love to do math homework.